Here in session 45, we're going to take a look at some additional strategies needed to solve simultaneous equations. In the first couple of sessions, we looked at adding the addition method and the subtraction method for combining two equations together such that it cancels out one of your variables. And then once one of those variables is canceled out, you go ahead and solve the remaining equation for the one variable that remains. Well, if we take a look here, we have a 5x plus 2y equals 14 in the first equation, 2x minus 4y equals 8 in the second equation. And if we take a look here, we have a positive 5x and a positive 2x, and if we either add these two together or subtract the two, it's still going to leave us an x value. They don't cancel each other out. And if we take a look here at our plus 2y and our minus 4y, if we either add or subtract these together, they also will leave us a y term, which will not cancel it out. So what we need to do now is look at a strategy whereby we multiply an equation here, one equation or both equations by a number, so that we can reach a position or a point in which we can then add or subtract the resulting equations and have it cancel out an x or a y value here. Well, if we take a quick look here, 5x, 2x, and then a positive 2y minus 4y. What if instead this first equation had a 4y in it instead of a 2y? Well, if we had a positive 4y and then we added these two equations together, our positive 4y and our negative 4y, our minus 4y here, would cancel each other out. Well, is there a way that we can change this first equation up here so that it has a 4y in it instead of a 2y? But we change it in such a manner that we have not changed the value of the equation. In other words, can we make an equivalent equation for this first one up here where we have a positive 4y in it instead of a positive 2y? The answer is yes. And the method by which we do that is by multiplying this top equation by 2. And the reason why is you need to use your distributive principle, your distributive property, or your distributive rule. When you are multiplying these things in parentheses here by a particular value, you have to take that number and multiply it by each of its parts. Well, what will 2 times 2y be? It'll give us the 4y that we're after, won't it? So what we're going to do here is multiply our first equation by 2. And I'm just going to rewrite the answer over here. So then, 2 times 5x. What's that? Well, that's going to be 10x. Then we take our 2 and we multiply it by our second term. What's our second term? 2y. And we have a plus sign. 2 times 2y is going to be 4y. But since we multiplied the left side by 2, we have to multiply the right side by 2. 14 times 2 is 28. Now let's just simply rewrite the second equation again. That'll be 2x minus 4y equals 8. Now at this point you can see that if we were to add these two equations together, our plus 4y and our minus 4y here are going to cancel each other out. So let's go ahead and do that. Let's add these two equations together. And remember, 2x minus 4y is the same thing as 8. They are the same value. So by adding 2x minus 4y to the left side, that's equivalent to adding 8 to it. And by adding 8 to the right side, we've in essence added 8 to both sides. And so therefore we have not changed the value of the equation at all. Okay, once again, we are adding. So what's 10x plus 2x? Well, that's 12x. Then what is a 4y, a positive 4y, plus a minus 4y? That's 0. They cancel each other out. So 12x plus 0 is just simply 12x. That's what we're left with on the left side. On the right-hand side, 28 plus 8 is 36. We are now left with 12 times x equals 36. To undo the multiplication of 12, here we need to divide both sides by 12. 12 times x divided by 12 is just simply x. And then on our right side, 36 divided by 12 is 3. So we found out that the x value for both, that'll work for both of these equations, is when x is equal to 3. Now then, let's go ahead and place that 3 back into either our first equation or into our second equation. Let's just go ahead and stick it into our second. If we put a 3 in for x, 2 times 3 is 6, minus 4y equals 8. So now what we're going to do here is solve this second equation for y. Our x variable is now gone. So our y term, our minus 4y, is being added with a 6. So to undo that, we need to subtract 6 from both sides of the equation. So a 6 minus a 4y, or rephrase, a positive 6 minus a 4y minus a 6 is going to cancel out our 6's here. So that then just leaves us with minus 4y on the left. Then over here on the right, 8 minus 6 is 2. We're now left with minus 4y equals 2. To undo the multiplication by minus 4, we need to divide by minus 4. So we need to divide the right side by minus 4 as well. What is minus 4 times y divided by minus 4? Well, remember, any number divided by itself, minus 4 divided by minus 4 is a positive 1. And a positive 1 times a y is just simply y. So we're going to be left with y on the left-hand side. And then 2 divided by a minus 4 is going to be a minus 1/2. So we now have found out that our y value is going to be minus 1/2. Well, let's just go ahead and stick this back into our original equation here. And because the blue is what we multiplied by here, I want to erase it so that we get back to what our original equation was, which was in red. And let's see if these two values here work. We've determined that x is equal to 3 and y is equal to minus 1/2. Let's stick the value back in. What is 5 times 3? Well, it's 15. Stick in a minus 1/2. What's a positive 2 times a minus 1/2? Well, it's a minus 1. What is 15 plus minus 1? Positive 14. Positive 14 equals positive 14. So we can see that these two values work for the first equation. Now let's try the second equation. X is 3. 2 times 3 is 6. Y is minus 1/2. Minus 1/2 times 4 is minus 2. But we're subtracting a minus 2. So 6 minus a minus 2 is the same thing as 6 plus 2. 6 plus 2 is equal to 8. 8 equals 8. So these values do in fact work in both equations. So that's our answer. X is equal to 3, y is equal to 1/2. In our second example here, what we actually need to do to solve these equations is we're going to have to multiply both equations by some number in order to reach a point in which our x's and our y's match each other, so that we can then either add them or subtract them together to cancel them out. Well, let's take a look here. You got a couple different choices. We have a 3x and a 2x here, and then we have a minus 4y and a 6y here. Now you need to start thinking of common multiples. Well, what is the common multiple of 2 and 3? 6. 6 is a common multiple. So what if we went ahead now and decided that we wanted to get a situation in where we had a 6x up here and a 6x down here? We could then subtract the two equations together. That's one option. Another option here is, well, we have a minus 4y and a positive 6y. If we can get these both to 12, our minus 12 here, our minus 12y, and our positive 12y will combine to wipe each other out by adding. So let's try maybe this method. Let's take a look at 4 and 6. What's a common multiple for 4 and 6? Well, the smallest common multiple would be 12. If we then had a positive 12y in our second equation and a minus 12y in our first equation, we could add them together and that would cancel out our y's. The question then is, what must we do to our first equation? What must we multiply it by so that we get a 12y over here? Well, 4 times what equals 12? 4 times 3 equals 12. So what we're going to do is multiply our first equation here by 3. If we multiply the left side by 3, we also have to come over here and multiply the right-hand side by 3. So let's do that. 3 times 3x is 9x. Then 3 times a 4y is a 12y. And we have a minus sign there. So we have 9x minus 12y on the left. Then on the right we have 6 times 3, which is 18. Now let's come down and take a look at our second equation. What must we multiply this by so that when we multiply it by our 6y we get a positive 12y? In other words, 6 times what is 12? Well, 6 times 2 is 12. So what we need to do in this second equation is multiply both the left side and the right side by 2. 2 times 2x is 4x. 2 times a positive 6y is a plus 12y. So that leaves us with 4x plus 12y on the left, and then 4 times 2 is 8. We now have 8 on the right. At this point, we now have a positive 12y down here and a negative 12y up here. We can simply add these two together and our y's will cancel. What is 9x plus 4x? Well, that's 13x. Our minus 12y and our positive 12y combine and cancel each other out. That leaves us with a 0. Then we have 18 plus 8 on the right, which is 26. At this point, we simply solve it for x. X is being multiplied by 13, so we need to now divide by 13 to both sides. 13 times x divided by 13 is just x. 26 divided by 13 is 2. So what we found out now is that x is 2, and that is what will work as the x value for both equations. Since we've calculated this value, what I'm going to go ahead and do is erase the stuff in blue that we did. These are the changes that we made to each of these equations by multiplying it by a particular number, because what I want to do is get back to our original equations, which are in red, and then what we're going to do is take this x equal to 2 and we're going to plug it back into one of these two equations. It doesn't matter which one we put it into, the choice is yours. Let's just go ahead and take our first equation and place it up there. X is 2. Well, 3 times 2 is 6, and that's going to leave us with minus 4y equals 6. So let's rewrite this first equation now as 6 minus 4y equals 6. Six minus 4y equals 6. Let's take a look at our y term. Our y term is the minus 4y here. It's being added with a 6, so to undo that addition by 6, we need to subtract 6 from both sides of the equation. What is 6 minus 4y minus 6? Well, the 6 and the minus 6 cancel out to 0, so that leaves us with minus 4y on the left. Then over on the right-hand side, what is 6 minus 6? Well, 6 minus 6 is 0. The y is still not by itself. It's being multiplied by a minus 4, so we need to divide both sides by minus 4. What is minus 4 times y divided by minus 4? Well, that's simply y. The minus 4 divided by the minus 4 is going to give us a positive 1, and the positive 1 times the y is just y. But over on the right-hand side, we have 0 divided by minus 4, which is simply 0. So what we found out is that when x is 2, y has to be 0. And that is the only solution to the problem. Well, let's go up here and double check by placing these values into both equations and see if it works. X is 2. 3 times 2 is 6. Y is 0. 4 times 0 is 0. 6 minus 0 is 6. So on the left-hand side, you're left with 6, and 6 does in fact equal 6. So that works. Equation 2. 2 times 2 is 4. 6 times 0 is 0. 4 plus 0 is 4. You're left with 4 on the left. 4 does equal 4. So we can see that x is 2, y is 0. That is our ordered pair, our solution that works for both of these simultaneous equations. And then lastly is a quick review. Sometimes in order to solve simultaneous equations, you've got to multiply both equations by certain numbers before you finally reach a point in which adding or subtracting these resulting equations together will end up canceling out the variable for you, or a variable for you. Okay, that finishes up session 45.